This is the solution for a question covering the sublearning outcome. Calculate net force on a 2D rigid body using free body diagram and equilibrium equation from Mechanic 1. In this question, we will move the force load P from point B to point D, and we will need to find the equivalent force to have an equivalent system with the same effect as the support reaction. We will first draw a coordinate system with positive force pointing upward and to the right, and positive moment rotating counterclockwise. And then we will identify the support at point A, which is a pin support, and the support at point D, which is a roller support. We will draw another system with the force in the new position. We know that when we shift the force, we will need to add a force and a moment at the new location to keep the system unchanged. Therefore, we will draw an unknown moment at point D, which we will name it M. Because the second system should be equivalent to the first system, we will take moments about point D with the system both before and after shifting the position. The moments about point D in system 1 should be equals negative AY multiply the perpendicular distance from point D, which is 9.5 meters, negative because it is causing a clockwise moment about point D, plus negative 20 kilonewtons meter, negative because it is causing a clockwise moment about point D, plus positive 50 kilonewtons multiplied by 4 meters, positive because it is causing a counterclockwise moment about point D. Don't solve the equation yet. We will label this equation 1 for later use. Now, we will look at the system after shifting the position. The moments about point D equals negative AY multiply the perpendicular distance from point D, which is 9.5 meters, negative because it is causing a clockwise moment about point D, plus negative 20 kilonewtons meter, negative because it is causing a clockwise moment about point D, plus the unknown moments M. We will label this equation 2. We now have two equilibrium equations that takes the moments at the same point. We will make them equals to each other. We get negative AY multiplied by 9.5 meters plus negative 20 kilonewtons meter plus 50 kilonewtons multiplied by 4 meters equals negative AY multiplied by 9.5 meters plus negative 20 kilonewtons meters plus the unknown moments M. Because we want to have an equivalent system with the same effect as the support reaction, which is AY in this case. Therefore, we know that AY must be the same, which we can cancel each other out in this equation. We can also cancel out the negative 20 kilonewtons meters because they are equals to each other. Now, we get the unknown moments M equals 50 kilonewtons multiplied by 4 meters, which equals 200 kilonewtons meter. In this question, we have found the new equivalence force after the force P was shifted from point B to point D. We need the force P, which is 50 kilonewtons, and a moment of 200 kilonewtons per meter at point D to have an equivalent system with the same effect before and after shifting the position. Now, we are shifting the position of the moment M from point C to point A. What will the moments have to be to have an equivalent system with the same effect as the support reaction? We will draw a system with the moments in the new position as shown below. We will set up an equilibrium equation and take the moments about point D with each system. The moments about point D equals negative AY multiplied by the perpendicular distance of 9.5 meters, negative because it is causing a clockwise moment about point D, plus negative 20 kilonewtons meter, negative because it is causing a clockwise moment about point D, plus positive 50 kilonewtons multiplied by 4 meters, positive because it is causing a counterclockwise moment about point D. We will label this equation as 1 for later use. Now, we can look at the system after shifting the position of the moment. We will take the moments about point D, which equals negative AY multiplied by the perpendicular distance of 9.5 meters, negative because it is causing a clockwise moment about point D, plus the unknown moments M. plus positive 50 kilonewtons multiplied by 4 meters. Positive because it is causing a counterclockwise moment about point D. We will label this equation as 2. Now, we have equilibrium equation for each system. We will set them equals to each other. Negative AY multiplied by 9.5 meters plus negative 20 kilonewtons meter plus 50 kilonewtons multiplied by 4 meters equals negative AY multiplied by 9.5 meters plus the unknown moment m plus 50 kilonewtons multiplied by 4 meters. We know that AY has to equals to each other. Therefore, we can cancel them out in this equation. We can also cancel out the 50 kilonewtons multiplied by 4 meters because they exist on both sides of the equation. Now we get the unknown moment m equals to negative 20 kilonewtons meter. We will draw the moments rotating in the clockwise moments on the diagram because the answer we get is in negative. In this question, we have shifted the position of the moments from point C to point A. The moments will remain the same, which is negative 20 kilonewtons meter, to keep the system equivalent to the system before shifting the position.